All right, looks like we're recording. All right. Any lingering questions about command line stuff as far as it relates to this class before we move on?
So, the pipe.
Okay.
All right. Apparently, I have a misunderstanding of how it works. I am under the impression that it takes an output from whatever's before it and applies it to whatever you put after.
It becomes the input to whatever you put after.
Okay.
That distinction may sound kind of like just weird semantics, but there is a difference. So whatever's on the left-hand side of a pipe, that output becomes the only input to the stuff on the right-hand side of that pipe.
All right.
So
why then would using the caret to move that input into another file not work after a pipe where you just do the caret?
Can you copy and paste what you're talking about into our copy paste area?
I sent you a message about it before and I was able to figure it out, but I just don't know why it didn't work.
Let me check on my chat here.
It was from a while ago. Probably last.
It was here on Teams, right?
Yeah, it was on Teams in our chat. Our personal chat.
I think I understand what you're saying, Dalton. So you're saying, why can't you just redirect that to the file instead of? So what's the difference between that and a pipe? Is that your question?
Well, I use the pipe and that. I'll paste it in this thing's chat. Exactly what I'm talking about. So this is what I tried doing for, I think it was number 2, and I just didn't need a pipe. I just needed to put the caret where the pipe was, and then just get rid of the pipe.
Okay, so you've got.
But do you see what I was trying to do here?
Of all the M files, and then you tried to pipe it to a directory.
Yeah, and I tried sending it to the directory and said, hey, name it that.
Okay, so let me do a quick edit of this and see if that makes sense.
And I figured it out, right? I just needed to essentially put the caret where the pipe was, and then that makes it work.
Almost. You'll have to give it the directions to that file.
Yeah, and then combine those two. So that's what I ended up putting as the answer, right? But I don't understand necessarily why that didn't work.
Okay. So yeah, I think you are kind of misunderstanding what the pipe is looking for. It's looking for, on the left side, anything. All right, it'll take anything as an input. So whatever we do on the left-hand side will give us some output. In this case, it was the number of lines for each of those M files. Okay. Now, that becomes the input for the stuff on the right-hand side. And what the right-hand side of a pipe is looking for is a program. You gave it not a program, but a directory.
Okay, so it's looking for, like, execute something would be a program, right?
Or another word count, or head, or tail, or cat, or
copy
echo.
Something.
Copy, yeah. So all those little commands, ls, pwd, all of those are actually little programs that just do one thing really well. And so pipe is looking for something on the left side, and it's that stuff that it gets from the left side, it's going to become the input for a program on the right side.
Okay.
And so
the caret's not a program. It's just
No.
telling your computer to move something.
The caret is a redirect.
Or read.
And so instead of printing it to your screen, it's going to redirect it to whatever file you give it. And in this case, ... data course hall /assignments/assignment2 mlines.txt was the file that it sent the output from word count to. So you didn't need a pipe there because first, it wasn't necessary since we were just doing one program. And second, the pipe wants to connect two programs together where the output from the first program becomes the input to the second program.
So if there is no program before the pipe that was working on something, right? There was no like copy or execute before it. It's also not going to work.
Yeah, because it won't have any input. The simplest pipe would be like one of the simplest programs is echo. And what echo does is anything that's in the quotes after echo, it just spits it onto your screen for you. That's all the program does. Okay. Now, you could redirect that from your screen to a file. So you could say echo 123 in quotes and send that to a file, and that file would then contain 123. Or you could pipe the output of echo. So instead of it going to your screen, it goes to become the input for the next program. Let me see if I can share my screen with you and just kind of play around with this a little bit.
I'm pretty sure I get it now. I just, that whole program thing makes a lot more sense. And now I know that if it's not working, it means whatever I'm trying probably isn't a program on the right side.
And it's a good bet, yeah. Okay, so echo 1, 2, 3. Can you see this?
Yeah.
All right. Boom. That program just spits it out onto your console for you to see, the human. Okay. If I hit up, echo 1, 2, 3, and then say word count L, what's that going to say?
It's going to say, hey, the program spit out of echo 1, 2, 3. I'm going to take and the whatever it spit out from that program and apply the program word count of the lines to it. So it should be one line.
Should be one. Boom.
Okay.
Yep. So the pipe is just there to link programs together to where the output of one becomes the input of the next. So it lets you chain things together. It lets you take a bunch of really simple programs and combine them into a sentence, basically. You're talking to your computer. You're saying, hey, echo 1, 2, 3, and then count the number of lines in that.
And that's a lot easier than doing each line manually, individually, copying whatever it was before, all that kind of stuff. Okay, yeah, I got it.
And it lets you compose pretty complex sentences. We don't know enough terms right now, like enough of these little shell programs. But as you start learning more, it lets you have a pretty in-depth conversation with your computer to where it's only limited by your creativity to string things together. So it can go a lot deeper than echo word count, obviously.
And then the other thing I wanted to kind of go over again would be the for loops. So I didn't end up using for the homework a for loop.
Okay.
I was able to hopefully get everything to work without using that.
For the for loop, let's abandon the shell for that because we're going to go over R today.
Okay.
Yeah, so we will cover that today.
No problem.
And honestly, I think it's easier to see in R because you don't have to do one line at a time in there. All right, other questions? Nothing? Okay. Well, open up your terminals.
are Git or R?
The right here, what I've got, your bash terminal.
Okay, bash.
Yep. Now, I want you to type the capital letter R and hit enter. You should see something like this.
Mine
Command not
just
found.
Yeah, that's what mine says too. Command not found.
Has everybody got command not found?
Yeah, that's what I got.
I also
Yep.
have command not found.
Yep. Mine's working.
It worked.
Cody, yours worked?
Yes.
Are you on a Mac?
Linux.
Linux, okay.
So it
Mine
looks
worked
like it
on a
works just for Linux.
Lacey, yours worked,
I have a
right?
Mac. It's
Yeah.
working.
Did it work? Yeah, or were you on a Mac and it worked? I guess that's the question I'm asking, if there's a difference between Mac and Windows here.
No, it works. I'm on a Mac.
Okay. So this may be a limitation of Windows. That's okay. You can just follow along with me. When I typed in R, it changed my little command prompt. Before, it was my name and $sign. Okay. The $sign being the standard prompt for, okay, you're in a bash terminal, give me some commands. Now we've got the little caret. And it also has told me, hey, you're using R version whatever, called holding the windsock, whatever that means. Great. Here's some stuff about it. Type demo for some demos, help for help, or Q to quit. I'm actually in R right now. So if you're on a Mac or Linux, it sounds like the capital R, enter, starts the R program. And so now, instead of taking bash commands, if I do pwd, it has no idea what I'm talking about. It's now switched languages on me. Okay, this is a little code switching. I can do cd ... and it's going to say, I have no idea what you're talking about. Okay, but if I do list.files, open and close parentheses, it's going to show me a bunch of files. Why did that work and the others didn't?
Because you're using R syntax now and not bash syntax.
I'm speaking a new language. Yep. All right. So I don't actually want to use R in my terminal like this. It's hyper annoying. I hate it. I hate it deeply. And so I'm going to hit Q, open, close parentheses to quit. And it's going to say, do you want to save your workspace image? And the answer is always no. So N, enter. Okay. I got my command prompt back for bash. I just wanted to show you that R is actually working in the background exactly like our terminal so far. It is a command line program in essence. But we get a special way of using it, all right? And that's RStudio. So go ahead and open up your RStudio. Make sure this is in a convenient spot for you, because we're going to be using it the rest of the semester all the time.
Are we going to want our command line still up frequently, or is that kind of done?
It's actually quite handy for Git still. And so keep it around, because if you got a bunch of files and you need to push them to GitHub, the command line's still by far the fastest way with git add, git commit m, and then git push.
Okay.
Yeah. If you're just committing 1 or 2 files, then we can actually do that through RStudio pretty quickly. I'm going to go ahead and close my terminal. So we just got RStudio up. Make it full screen. Okay. Let me know when you have it up. I've got the little hand raise feature now, so you can raise your hand or just shout at me.
I've got it up.
Okay. Does it look like this?
I have mine up, and yes, it
Yes,
looks like
looks
that.
very much like that, except it's not black.
Not black. Right. Okay. So once you got this up, we're going to do some quick setup. This is just something we all have to do to be on the same page. Go up to Tools, and then Global Options. It's the last choice on the tools there. Okay. So Global Options, I click on that. Now, I want you to uncheck this box because it starts out checked. Say no, and then make sure that Save Workspace to R data on exit is never. Those are the two most important things. Okay. I think it's also pretty handy to make sure that these two are unchecked. Okay. So uncheck those first three boxes and Save Workspace to R data on exit, never, and then hit OK. It's going to say you need to restart RStudio. Say yes.
Sorry, I didn't catch that last part. Could you do that really quick one more time?
All right, so Tools, Global Options. Make sure that this box, and this box are unchecked. And then make sure this says never. And then just hit OK. And restart. Yes.
Okay, thank you.
Mm-hmm.
Well, mine never asked for a restart, but I think it did it.
Okay, that's fine. As long as you hit OK and didn't hit cancel on accident. All right, and look at this. It's telling me the same stuff that it said before in my little command line terminal. Does yours say something like this?
Yep.
Yeah.
What
Yes.
version of R are people working with? I've got 3.6.3.
4.0.2.
Ooh, fancy.
Mine's
Oh.
also the 4.0.2.
Okay,
Mine is too.
awesome. All right, that shouldn't be a problem. They changed a few things in this 4.0 upgrade, but it doesn't affect anyone who's not like a hardcore R programmer. So I think we're going to be fine. All right. Now, getting to know this RStudio program, if you prefer the black background, you can go back to Global Options and then click on Appearance. Okay. I've got mine set to Merbivore because I just like that particular color scheme, but there's plenty of color schemes you can pick from. So find one that suits you, doesn't matter, and then hit OK. All right. I just find it easier on my eyes. Now, when you first open RStudio, it comes with three little windows. This first one is our console, over here on the left, the big guy. Then the top right is our environment, and it's got a little history tab, and it's got connections, okay. And then the bottom right starts in files, but we also have a space to view plots. We've got packages, nice built-in help, so we can be reading a help file while we're writing code. This is awesome. And then a viewer. All right. So I look at files. What files do you see? Do you have these same ones? Does anyone have a folder called ITSX 1.0.11? I doubt
No,
it.
they're the files from my computer.
They're the files from your computer. So
Yeah,
already
same here.
we got a problem. We're working in different environments. So the files I see are different from the files you see. So how are we going to write file paths that we can all use together?
Get in the same environment.
How?
We listen to the teacher in the next couple minutes.
Oh.
We go to data course, maybe. Bring it to data course somehow.
Yeah, we all want to be in data course, and in particular today, we want to be in assignment 3, that folder. So let's create an R project. Who has actually done the reading here or watched these videos? Oh, I'm guessing that's nobody. What a shame. All right, those are part of your assignments for this week. Okay. This first video is what we're about to do, so we're going to walk through that. But I do want you to read about what a package is and what R projects are. Okay. That's what we're about to set up, is something called an R project. Now, R projects were developed because people want to work in the same environment as each other all the time. We want file paths to be portable from computer to computer. And so what people have typically done is an entire project or analysis or whatever has been self-contained in a single folder. Right? So you've got a folder for whatever analysis you're doing, right? Some chemistry lab or something. In that folder lives all of your R code, all of your data, and all of your output, like graphs and figures and statistical tables. Okay? And that way you can just take that folder, give it to somebody else, and it's going to work, because the file paths all start from that folder and they don't go outside of it. They only go down into the other subdirectories. Okay. That's been such a common kind of workflow for people that RStudio developed something called an R project that kind of enforces that. Right, so I'm going to get back into R here. I'm going to go File, New Project. Okay. Raise your hand when you get this new project thing. All right, there's everybody. We're going to go with existing directory because we already have a directory that we care about. So existing directory. And now it's going to want us to pick the directory. So I'm just going to go to Browse. I'm going to find Desktop and then Data Course, my last name. Okay. We all there? Once you get to Data Course, your last name, just click Open right here. Okay. So that is the path to the directory for my R project. And then I'm just going to click Create Project. Boom. Okay, what has changed over in the bottom right? I'm
The
guessing,
directory it shows.
Inside their data course.
I'm guessing you're going to see similar stuff to what I'm seeing right now. Because last class period, we all made sure that we had assignments, code examples, and data in our personal Git repositories, right? So if you did that correctly, you're going to see assignments, code examples, and data. What this has done is it's created a little file. In my case, data course Zon. In your case, data course your last name. I can actually click on that file, and it's just going to like preview it for me. It's kind of like cat. Okay. It's basically saying this file right here is just a bunch of parameters. Okay. Restored our data, default, default, default. Okay. Neat. But what that little file does is makes everything that we do subsequently, if we're working in this project, makes it begin in this directory. So data course Zon for me. All right. Now, we're going to go back up to File, and instead of New Project, we're going to say New File, R script. There's actually a shortcut for this. It's so common. Control-Shift-N or Command-Shift-N. I'm going to click on that. And boom, I've got a fourth window now. All right. So down here, this is our console. This is the guts and the behind the scenes of what's happening in R. Up here, this is a little script. So we can write R code without having to hit enter every time in our terminal. Okay.
I have a question really quick.
Yeah.
When I did the new project,
Mhm.
it didn't have the desktop thing in front of the data course, my last name. So I just have it just did like all the assignments. Is that a problem? It doesn't have like assignments, code example, and data. Does that make sense? It just has the assignments. and
Just
everything.
assignments?
Yeah.
Right there?
Do I need to redo something?
No, what that means is that in your data course Bowen,
Uh-huh.
you haven't moved code examples and data in there yet. So what I would do is either through the command line or through your little like file browser,
Uh-huh.
go in there to data course, copy those code examples and data, then go back to data course Bowen and paste them.
Paste them in there.
Mm.
Okay, I'm pretty sure I have them in there already. It should just be inside of the data course Bowen that I have all three of those, right?
Yeah,
Okay, I have them already, but I just am not.
but it's not turning up down here.
Yeah, it's just like one step beyond that. Probably if you were to open assignments.
Like that?
Yeah, that's what I have in there.
Oh, okay. Type in get WD, open close parentheses, and hit Control Enter. Control Enter is our run this line of code, or Command Enter if you're on a Mac.
Okay, Control Enter.
And you can see it actually spits stuff out down here for me.
Okay.
What does yours say?
It says error. Error and get W. Oh, I did WC. Okay, let's try that again. WD.
Get working directory is what that stands for.
Okay. So now it says users / Lacey Bowen / data course Bowen.
Okay. That sounds right.
Okay.
All right, so I think you're in the right spot. If you look over here on my right side where I've got assignment, all my assignments listed, I can go up into this little bar here and click on different things. It'll let you see files outside of where you are, as long as when you do get WD and it says data course Bowen, then you're good to go.
Okay. So yeah, so mine just has that same thing, but it goes home straight to data course Bowen.
Okay.
It skips the desktop thing. So that shouldn't be a problem.
Yeah, that's all right.
Okay.
Everyone's absolute file paths on their computer look different. That's why we're doing this R project. And so I don't expect you to have this same part. I just expect it to say data course, your last name at the end.
Okay, perfect. Thank you.
All right. So go ahead and type in a hashtag my assignment 2. See how that actually came out to be a different color. What's a hashtag?
It's a
Anyone
comment.
done coding before?
That's a comment.
Comment. That means that code won't be interpreted by your computer as R. It's just for you, the human. Okay. So I'm doing my assignment 2, and then I'm going to hit Control S to save, or you could go up here, File, Save. And it's going to say, what do you want to name it? All right. First off, we're in our data course last name. We actually want to save this script in assignment 2 because that's where we are. So I'm going to go to assignments, assignment 2. And I'm going to say assignment underscore 2.
Shouldn't we be in assignment 3 right now?
So sorry. Yep, that's 3. Assignments, assignment 3. Thank you. Okay. Don't hit enter yet. We don't want to overwrite the assignment 3 that's already there. So I'm going to say assignment 3 practice.r. Okay, once you got that in, save. You'll see the name of it pop up here in this tab. And I'm going to actually change that to my assignment 3 and hit Control S again to save. Okay. What have we done? If I go into my assignments down here in my little file browser, click on assignment 3, I'll see assignment 3 practice.r right there. If I were to open up a terminal and say repository, data course, Zon, assignments, assignment 3, and look around, I've got a new file. Okay, so we made a new file. Its extension is .r. Okay. Any file with the extension .r is going to be interpreted by your computer as being an R script. What is an R script and how is it different from just typing in R code? Well, it lets us work with the script, practice things, try it out, see what's working, and then save it. And it's a record of all the steps we did for an analysis. Okay, so that's what our R script is. I want you to open another file. For me, that's Control O. It may be Command O for you, or you can go File, Open. And I want you to open assignment3.r. All right, so this is pretty convenient. It lets us have multiple scripts open at the same time. So I've got my little practice one here, and I've got the regular assignment 3. This is what we're going to be going through today. All right. Let me know if you are not at this point. Everyone good? You got assignment 3 open?
Give me 1 second.
No problem.
Let's see, it looks like I have the assignment 3 from last spring. I'll need to kind of...
Do a git pull.
Yep.
Yep.
Was this one not inside our last name one, but instead something else, or?
No, it's inside your last name one. As long as you copied everything from the regular data course to data course my last name. If you moved that whole assignments folder over, copied it over, then you should have this. So Control O, it's in data course Zon or your last name, assignments, assignment 3, and then there's the file.
Yeah, it's there.
Okay.
Let me try to open that again. So yes, file, open file, assignment3.r.
.r, yep. And you can just double click that or hit open.
Oh. It closed the last one I had open, I think.
You can just reopen it if you accidentally close your assignment 3 practice. You can just reopen it. You can also rearrange these tabs any way that you want.
And how did you reopen it there? What command did you use? Or
Control
what?
O,
Okay.
and then I just double clicked on assignment 3 practice.r.
What does the .r history do?
Do you have a .r history here in your assignment 3?
No, right here by where the assignments are open, like right next to it. I don't know if that's
Your
needed.
.r history, it's not always going to be there, but it's the same as clicking on this history tab up here. It's a
Okay.
It's kind of like a fossil record of the recent commands. By default, I think it stores the last 1,000 things that you typed. So if you typed something and deleted it and forgot what it was, you can go back to your history and kind of scroll up and find it.
Okay, thanks.
Mm-hmm. For the most part, we're going to be doing all of our work up here in the top left in one of these R scripts. Okay. The output from that is going to be displayed down here in the bottom left in our console. And we want the top right typically to be on the environment tab. We've got history, connections, and if you're in a Git repository, which you should be, you'll have a little Git tab. So you can actually do your staging, like your Git add and commit and push from RStudio, but it's a lot slower if you're doing multiple files. For the most part, we're going to want that to be on the environment tab. That tends to be the most useful one, and that's the default. Okay. Then down here, we've got our files, plots, packages, help, and viewer. For now, let's just leave it on files. Okay. So get the assignment3.r open. It should look like this in whatever color scheme you have set. Okay. And let's go through it. And remember, the magic keystroke for RStudio is Control-Enter. If you're on a line and you hit Control-Enter, it will run that line of code. So the code 1:10, what does that do?
Provides integers 1 through 10.
That's it. And here's the output, 1 through 10. This little 1 in the square bracket is just saying this is the first line of your output. Okay. Now you've seen this one before. We used it talking about for loops briefly last time. Control-Enter on letters. What's that do?
Lists all the letters.
A through Z in lowercase. If I type in capital LETT, look at this. It gives me a little drop down. That's really handy. I can move up and down with my cursors. This helps you avoid misspelling. Okay. So there's letters in all caps, Control-Enter, and there's my letters in all caps. Okay. So we've got a little square bracket 1 saying this is the first of the letters. And down here we've got square bracket 25 saying that's the 25th, and so that must be the 26th. It should not shock you that there are 26 letters in the alphabet. Okay. So R is considered a vectorized computer language in that it likes to work with vectors. Does anyone have experience with what a vector is?
Is that just a way to store a bunch of numbers or something? Well, that's an
Yeah,
array.
That's exactly it. It's a one-dimensional, almost list of things. So whether that's a bunch of letters, a bunch of words, a bunch of numbers, okay? So you've already looked at some vectors here. This is a vector of 1 through 10 integers. And it has some properties. First, it's one-dimensional. Okay. It's not like a spreadsheet where there's rows and columns. This is just basically like a column. You can think of it that way. And it's got a length property. What's the length of 1 through 10?
Well, probably 10.
Yep, you got it right. It is 10. All right. Now, that's all well and good, and we can do mathematical operations. We can say 1 plus 10, and we get 11. Hooray. This is a really powerful calculator. Okay. But we can also store values as objects. So this first one, I've got vector 1 and then this weird symbol. What's that look like? A little arrow pointing to the left. You can either type it out or you can hit alternate minus or alternate dash, alt dash, and it does it for you. And that's a little savior for your fingers because you're going to be typing that a lot. That's the assignment operator in R. Whatever's on the right of that gets assigned to whatever is on the left of it. So if I say X alt dash 3 and hit Control Enter, go ahead and try that. What happened? Nothing got popped out down here. But did you notice any changes in your RStudio screen?
Isn't the value of 3 assigned to the variable x?
It is. So now x equals 3. And up in our top right, we've got it there. This is what this top right is so good for. This is our environment. It's showing us all the values of different variables that we've got. And it's saying x has a value of 3. Okay.
Will it wipe that the next time you run the program, or does it keep it?
It will delete it when you close R. We wanted that function. So when we went to Tools, Global Options, and said save workspace to R data on exit, never, we're telling it that we want it to delete that every time it restarts. Okay. That's a feature, not a bug. Okay. This saves us from accidentally typing x plus 1 and getting an answer we didn't expect because we forgot that x used to equal 3. Okay. So y equals 5, or y alternate dash 5, Control Enter, and look, we got y up there also in our values. So now I can just say x plus y, and what do I get? 8. That's pretty handy. Okay. But it's not super handy, because what if we're working with big data or even tiny data? It's never just going to be one value, right?
You'll have to add vectors together, perhaps?
Yeah. So here we can, I'm going to demonstrate just by these 3 lines of code here that R is a vectorized language. Anything you highlight in R and hit Control Enter, it'll only run the highlighted portion. So you don't have to do things one line at a time. I can just go over here and highlight the C, open parentheses, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, close parentheses. If I highlight that, okay, and hit Control Enter, it's just going to spit out 1 through 10. So what does the C function do? We get the same results as just typing 1:10. It sticks things together and makes a vector out of them.
Oh, does it stand for concatenate by chance? Or?
It does stand for concatenate. Yep. This is kind of annoying behavior because you can never really have a variable named c. That gets really confusing really fast because there's already a function named c. Okay. In R, functions are always the name of the function and then open close parentheses. And they act on whatever's inside of the parentheses. Right? So in this case, we're concatenating, and concatenate takes things separated by a comma. Right? So I'm going to hit Control Enter on vector 1, that line there. And I'll look over here in my global environment in the top right, and vector 1 is there, and it gives me a bit of information about it. First thing it says is NUM. It's numeric. It's telling us that the stuff inside this vector are numbers. And then it says 1 through 10. That's actually not the numbers 1 through 10. It's just telling me that I have a length of 10. So when I run vector 2 here, Control Enter, vector 2 pops up. It is numeric. It's also 1 through 10 because it's a vector of length 1 through 10. But the contents are not 1 through 10. It's 5, 6, 7, 8, 4, 3, 2, 1 through 10. Okay. And then I can say vector 3 is equal to letters. Vector 3, CHR, what's that stand for?
Character.
Characters. So that's words, letters, that kind of stuff. We've got 26 of them, and it shows us the first few just so we can get a feel for it. A, B, C, D, E. Okay, great. Okay. If I say vector 1 plus 5, what's the answer going to be?
Would it be 6 and then 5, 6, 7, 8, 9, 10, the rest?
Or will it just freak out?
It's gonna add
freak
5
out.
to each one of those, right?
This is where R gets really handy really fast. It will add 5 to every element in that vector, and it'll do it real fast. So it's adding 5 to 1 and adding 5 to 2 and 3, and so we get 6, 7, 8 through 15. Vector 2 divided by 2. Control Enter. Each one of the numbers in vector 2 gets divided by 2. Okay. Vector 1 times vector 2. How's that going to work?
That's like a matrix, isn't it? Where
So that's gonna multiply each one of the numbers by the location, right?
Yeah, by the location, by the corresponding.
5 by 6, 3 by 7.
Yes. So yeah, that's exactly right. It's gonna multiply 1 by 5, then 2 by 6, then 3 by 7. Okay. So vector 1 times vector 2. Control Enter. There's our values. Okay. Vector 3 plus 1 is an error. How come?
You can't add integers and letters together.
Yeah, letters don't have any inherent numeric value whatsoever. What is A plus B? Well, that's not a thing. You can't do that unless A and B are objects that you've stored over there. I can say what is X plus Y right now, and R will be fine with that, and it'll say 8.
Yes.
But if I say what is X plus A, Control Enter,
Error.
it says object A not found. So it saw that X was 3, and then it went and looked for A, and it couldn't find it, and so it's not going to do anything. All right. So that's a vector. It's a one-dimensional list of things. It can be of many types. It can be numeric. It can be character. It can be a factor that we'll see later. It can be an integer, which is a special kind of numeric. Okay. Vectors need to all be the same type, though. that kind of gets confusing. If I concatenate 1 and A in quotes and 2 and B, I'm going to concatenate those together. I got 2 letters and 2 numbers. I tell R that these are letters because I put them in quotes. Hit Control Enter. What's our output?
Is it for string?
It's all characters. It converted our numbers into characters automatically. What it tried to do there was find kind of the least common denominator. It'll automatically try to make everything in your vector the same type. It doesn't know how to turn A into a number, but it does know how to turn the number 1 into the text 1. Does that make sense? Just by putting quotes around it. And so rather than try to turn A and B into numeric, it was able to turn 1 and 2 into the character version of themselves. Let me demonstrate how characters can't be added. If I put 1 plus 2 in quotes, Control Enter, it says those are non-numeric. Okay.
Can you add by typing out, 1 plus 2, where it's, ONE plus TWO?
No. It's going to look for something called 1 and look for something called 2. And it's going to give us an error on the first thing. And it's going to say 1 is not found. Object 1. So it's looking up here in our environment. If you don't have something called 1, it's not going to know about it. So this is where our like top right tab becomes real handy for us. I see this error, object 1 not found. Huh. I could go up here and look for something called 1. Oh yeah, it's not there. Okay. Now let's run this line of code, data iris. So I can just highlight that, or I can just hit Control Enter. This is a built-in data set. Okay. The real famous data set used for teaching statistics and such. Right. So we're going to use it a lot in this class. I promise you're going to hate the iris data set within a month. But that's okay. Now, up in the top right here, it says iris promise. That just means that we've told R we want you to load the data. That's what the data function did. We want you to load the data called iris. It's built in. Okay, if we spelled it wrong, it's going to give us an error. Load data iris T. Data set iris T not found. All right. So we're going to make sure it's spelled right. Run that. All right. So that's how you load built-in data. We'll be using iris a lot. Next up is question mark iris. This is your best friend, the question mark. If I hit Control Enter on that line, woo, look what happens. Did that happen to yours?
Yep.
What is it? It's our help file. Okay. The question mark gives us help on anything. So I could say question mark C.
So this is like the man for R.
Yeah, but what's awesome about it is that it sticks it in your lower right-hand side so you can look at it and you don't have to have a bunch of screens going, okay? And you can scroll through it. So C works that way. I can do question mark list.files. So there's the help for it. It's saying list.files. Here's the different parameters that it can use and their defaults. Okay, we'll get more practice looking at help files, but for right now, let's do the iris one. Edgar Anderson's iris data. Okay. Famous iris data set gives measurements in centimeters of variables sepal length and width and petal length and width for 50 flowers from 3 species of irises. Okay. So we've got Iris setosa, Iris versicolor, and Iris virginica. Okay. Then it tells us a bit more about the data. 150 cases, those are the rows, observations, and the 5 variables, columns. Here are the names of those columns. Okay. Let's take a look at this. I'm going to say capital view iris in parentheses. Hit Control Enter and it's going to bring up a new tab for you. So we can always switch between our tabs, but one of them now is our iris dataset. This should look familiar to you. It's essentially a spreadsheet. We've got rows and columns. I did that wrong. Rows and columns.
Hold up a second.
Yeah.
Show me when you type. Oh, view has to be a capital V.
It does have to be a capital. Yeah.
Okay.
Capital V view.
So R is also case sensitive, I've noticed, right?
Uh-huh. Oh, yes. All right, so we can scroll through this. We can scroll all the way down, and sure enough, there are 150 rows, just like it said. Okay, 150 cases, rows. And we've got some different measurements here. They measured sepal length, sepal width, petal length, and petal width, and they also measured species, right? They determined which species of iris it was. All right, so how many dimensions does this object have, or iris?
3. Would it be down, over, and then, let's see here, length, width.
It's got length and width, and that's it.
Oh.
It's got rows and columns. We will get to 3-dimensional data sets by the end of the class period, but they're pretty weird to work with. Most of the time, I'd say 90% of any data scientist or even bioinformaticist, they're working with 2-dimensional data, typically. And that makes sense. This is what Microsoft Excel is all about, right? It's a table. You've got columns and you've got rows. So this is the first data set we're looking at in this class. It's pretty simple. It just has those 5 columns. You can see how they're named up here, and then it's got 150 rows. So each row is an observation of a single iris that somebody found. Okay, so Anderson, whoever that was, went out, found an iris, measured its sepal length at 5.1, sepal width of 3.5, petal length of 1.4, petal width of 0.2, and determined that it was the species setosa. So that entire row is a single observation. Okay. We have 150 observations. I want you to remember this. Rows are observations. Columns are variables. Okay. So the row is the thing you're observing. The columns are the things that you're observing about that individual. All right, so I'm going to click back on my assignment 3 tab. And let's just run through these somewhat quickly, hitting Control Enter, starting here with dat arrow iris. What's that going to do?
Assign iris to dat.
Yep, Control Enter. And look at this. Over in our environment, we have a new variable called dat. That's pretty commonly used in R stuff because it just stands for data. Okay. You don't have to do that. I wanted to show you that you can. It didn't erase Iris either. Iris is still there. But Dat is there too. They're just clones of each other. Now, let's run through these. Control Enter on names. What's that do?
Names.
Shows the variable names.
Variable names. Sepal length, sepal width. Okay. Dim. Got 150 and 5.
The length and width of that data set.
The number of rows and then the number of columns.
Probably stands for dimensions, I think.
Dimensions, yep. How about head?
And it gives us that table we saw, but only the top of it maybe. Yeah.
Yep. In R, it's the first 6 by default. Okay. Now, we get little neat syntax when we're working with two-dimensional data like this. This is called a data frame. If I click on the little blue and white arrow next to Dat, it'll show me my column names and give me an idea of what's in there. First 4 are numbers. Fifth one is factor with 3 levels. Okay. If I know the names of my stuff, I can just type in Dat and then $, and look, it gives me a nice little drop-down menu. The $, lets you access columns of interest in a data set, in a data frame like this. So Dat $species just spits out all that entire column. Dat $sepal.length, note the capitalization, gives me just all the sepal lengths. Okay. All right, Dat square brackets, 1, 1. What's that?
It prints out the first row, first column.
Yep, 5.1. If I look in here into my iris, row 1, column 1 is 5.1, right there. So that's how you can tell R to look at little subsets of your data. So here I'm saying first row, first column. What about this one?
That's rows 1 through 3 when you go 5 down, or something
Rows
like
1 through 3, and
Yeah.
then the 5th column.
fifth
In our case, column number 5, 1, 2, 3, 4, 5 is species. And so it gives us setosa, setosa, setosa. All right. R always does this. You can access stuff with square brackets, even if it's one-dimensional. You can say, like, letters square bracket 3. What's that going to give me? A, B, C. The third thing in the letters. Okay. But since this data set is two-dimensional, not one, we have to give it 2 locations. First, what row or rows we want, and then what column or columns we want. So I could say 4 through 5 there, and it's going to give me rows 1 through 3, columns 4 through 5. Pretty handy. Okay. Go ahead and run this plot. What have I plotted there? Looking at that line of code. What happened?
Are you plotting sepal length against itself?
Nope.
Or no, that's
No, against pedal length.
Yeah, there we go.
I got a box plot.
You got a box plot?
Mm-hmm.
Interesting.
Box
I don't want to get into that error yet. We don't have enough time left in today's class to get into it. We'll have to pick that up on Monday. All right, what about, oh, was it this that you got?
Yep, that's it.
Okay, so you ran both of those lines. Try running just this line here.
Gotcha.
That shouldn't be a box plot.
And yep, works.
Okay, good.
It's
We
just
can
that it
save
does-
that error for like 2 weeks from now.
It runs the second one after the first one, and the second one replaces it.
Yeah, it replaces it. So there's our first plot. There's the second plot. Over in the plotting window, it actually gives us a little back arrow, this little blue one. So we can go back through and see previous plots that we've made. Or forward and see the more recent plots. Okay. That's pretty handy.
Yeah.
All right, so those are your first 2 R plots. The plot function, if I type in $plot, oops, on its own line, Control Enter, generic XY plotting. Okay, you tell it a vector for the X and a vector for the Y, and it plots it, and it tries to find the best plot for you. Okay, in the first case, they were both numeric, and so it was really easy for it to make a dot plot. Does that make sense? We have petal length on the X. That's a numeric vector. We gave it sepal length on the Y. That's also a numeric vector. Okay, so it was like, oh, these are both numbers. I can make a dot plot. The second one, on our X-axis, we gave it dat $species, and that just means dat, the column named species. It can't plot the words setosa, versicolor, and virginica in a numeric way, right?
Yeah.
Those are categories, they're not numbers. And so by default, when we did that, it said, okay, well, the y-axis is definitely numeric, so we'll plot that on a numeric scale. But the x-axis, these aren't numbers, so we're just going to put categories, and then the default plot for that in the plotting function is a box plot. So already, with just a few simple commands, we're starting to like get a glimpse of our data set here. Which species has the biggest sepal length, the longest sepals?
Virginica.
Virginica, okay. Is it significantly different from versicolor? I see
Yes.
a lot of overlap between the error bars there.
Yeah, I'd still say it's significant.
Okay.
Yeah. Because the bottom for Virginica is the average for
Right.
versicolor.
Okay, so who's had statistics? What test would you use?
You'd use like a 2-sided t-test or something, or
T.test. Look, that's built into R. Okay. So let's do a question mark on that. Student's t-test performs 1 and 2 sample t-tests on vectors of data. Okay, so we can give it an X and a Y. So I'm going to delete the question mark there and say X equals what?
Dat $species.
Dat $. Well, we can't do species.
Sepal length.
We cared about sepal length. And so then what is Y? Could we do that? No. Because it's not comparing numbers. Okay. We need to give it a subset. We need to say, look at the sepal length for Virginica and the sepal length for versicolor. Okay. put a pin in this. We'll come back to it next class period. But R does make a nice t-test pretty easy. Okay. And I tell you right now, they're actually not significantly different. Okay. Next up, we've got a new command, a new function called class. If I do class dat $ petal length, and it says numeric, what's the class function do?
Returns the data type.
It returns the data type of whatever vector or object you give it. If I look over here in my environment, dat $ petal length, it's actually already telling me that up here in a little preview. It's saying it's NUM, it's numeric. Okay. Dat $ species, it says it's a factor. Sure enough, it's confirming what I see up in the top right. Okay. There's a little shortcut to look at everything at once called str, that's short for structure. So the structure of dat. Recognize this output? It's just what we see up here by clicking on this little blue and white arrow. Okay. I am going to stop here for today before we get any deeper. And we'll hold off on assignment 2 or assignment 3 and 4 for Monday. We'll be able to get through both of them. But I wanted to take the last however many minutes before we have to leave for your questions. This is moving kind of quick. I realize that. I wanted to spend a lot of time making sure that we had our studio set up and we kind of knew what the different plotting windows are and everything. The first few lessons that we do in R are going to be kind of like this, where I'm not going to have you writing a ton of code. I'm going to be having you control enter and look through code just to kind of get a feel for things. So don't worry if you're feeling a little bit out, but if you have any muddy points or want clarification, please let me know.
So assignment 3 and 4 are not due until Monday?
Yeah, we didn't get there in time.
Okay, thank you.
Yeah.
I had a question
go ahead.
about. Oh, sorry. I had a question about the variables. Could you, probably an obvious question, but could you take variables and then put them into a vector as the variables? So like we made X and Y.
Oh, yeah.
Put C, X, Y, and then make them a new vector.
So C, X, Y gives us 3 and 5, because that's what they are up here, 3 and 5. And yeah, I could say that Z is C, X, Y, and sure enough, Z will pop up here. And now it's a vector of length 2, and the contents are 3, 5.
Okay.
Yeah. You actually wind up doing this a lot. Like, imagine mathematical functions that you can kind of easily put together with this, right? You're calculating some aspect of an equation over here, another aspect over here, and then stick them together. It becomes pretty useful.
I was just gonna ask, as far as like up until Monday, what would you say is the best way to like practice this stuff?
Go through this entire script, control entering each line. I've put a lot of like little notes on here for you. So you should be able to kind of follow along with yourself. I just want you to kind of see what's going on. Okay. You can see that we've got 4 loops down here at the bottom. See if you can figure those out. And then practice subsetting. So we did that with iris right here, or with dat, which also is iris. So see if you can get just the species Virginica and the petal width. Let me quickly show you what that would look like, because we were doing our little t-test somewhere. There it is. So don't worry if this goes a little bit fast for you. Virginica sepal length is dat, where dat species is equal to Virginica, and then the column is sepal length. I'm going to copy that, paste it here, and just change the name to versicolor.
So you're creating new variables so you can run the t-test, right?
Exactly. And so now I can, instead of dat species or whatever, I can say versicolor SL, and my X is Virginica. Oh, Virginica. I see. Virginica. Okay. So there's two sample t-tests, right? So I made new variables. The first one, Virginica SL, if I just highlight that and hit Control Enter, I'm just looking at sepal length for that particular species. And so the power of this lies in the ability to kind of subset. We'll get into this next class period, but give it a shot with what we've done already. Like the first 50 rows are setosa. So knowing what we already know, we could say dat 1 through 50, and then 3. What would that give us?
The petal length of all of setosa?
The petal length of the first 50 rows, which happens to be just the setosa. Okay. So that's, then I could call that petal length set for petal length setosa and save it over here. So I've got a new vector I can play with. So play around with this, keeping in mind that it's always rows, comma, columns, always in that order. Okay. And then just kind of go through this, hitting Control Enter, seeing if you can figure some stuff out. As far as practice goes, I've got some practice stuff for you. Okay. So in week 3, definitely do the vectors practice. Okay. Definitely do the indexing. And then as you have time, do the rest of these. Okay, because there's a nice practice for doing for loops, but you may want to wait until we've covered that first, unless you're comfy working ahead. But the vectors practice, come on. All right. So these are little like mental exercises. Okay. Consider a vector, and it's gonna, I'm not letting you copy and paste. I want you to type that in and then type this in and see what goes on. Okay. See if you can figure it out in your head first. So if X is this vector, what is the value of that vector less than 7? Is 4 less than 7? Yes, so that's true. True, true, false, 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 true, false. So which one of these meets that pattern? So it's a nice little series of like brain teasers for you that will help you kind of figure out how vectors work. The indexing is practice for how we identify using parts of an object using the square brackets. Okay. With that, we are out of time. So I'll stick around for a few minutes if people have burning questions, but then if not, I'll see you on Monday. Spend at least an hour doing these exercises. open and close R, get used to things.
Thank you.
I have a completely unrelated question. If nobody
Okay.
else has anything, for fungi class,
Uh-huh.
do we not have a paper that goes along with the quiz this week?
No, no paper.
Okay. Thanks.
Mm-hmm.
I have like, I'll turn my video on here. Just a question about the lab, our lab that Trevor and I are doing.
Uh-huh.
Okay, so I couldn't talk to you guys last week because I had to run to the dentist, but he talked to you, right? And he was saying that you were recommending using the square pots that we already have, right? So I kind of mentioned this in when I messaged you on Slack, but my concern with those is just that we won't be able to see the roots, and also that we'll be drawing in. It will produce a 3D structure basically, but we'll be drawing in 2D, right?
Yeah. I have seen other people do this. Apparently, it's a thing, and people are just drawing what you see as it's two-dimensional, and that the R package that we'll be using can take that into account.
Okay, cool. So
I get it's some kind of magic. I don't understand how it works, but I've seen like 3 papers do exactly that. They got it published. They use that exact technique. They use square pots. So okay.
Okay, perfect. We'll give it a go then. Do we still have the radish seeds somewhere? Do you know?
In the fridge, the big fridge in the lab.
Okay, they should be in there.
They should be in there. Yep.
Okay, we'll probably test run in that just at the get-go once we get some of this soil going.
Yeah, because they're fast growing. Yeah.
Yeah. And then I'm gonna run over to the school today and get that room number of the autoclave so that hopefully our ID cards let us into that.
Cool.
And then, I can't remember if Trevor mentioned this also, but we're both thinking, as far as our project goes for this class, would we be able to use the research we're doing, or would only one of us be able to do that?
You can both do it and you can work together on it.
Oh, sweet.
Yeah.
That'd be cool.
Yeah, I would encourage you to do exactly that. My concern would be that by the end of the semester, you're not actually going to be done collecting data.
Right.
So we can do it with like the radish seed test trial. And that'll work. And so then when you do have your data, all your code's going to be done already. You can basically just hit Control Enter a few times and be done with your analysis.
Okay.
Yeah.
That's great. Cool. I'll talk to him about that.
Okay.
As far as when we do the radish seed test run stuff if we're going to use that for the our project that we're doing for class, how many would we need to do that? I guess, how many trial runs? I can't think of the word.
At least 20, so we can have good data. Yeah.
Cool. And then
statistical tests will be tough.
Yeah. Should my card also have access to getting us into the greenhouse still, or should I message whoever the greenhouse manager is?
I can take care of that.
Okay.
Actually, send send him a message and just CC me on it.
Okay.
And so I can just reply yes, permission. But it's actually up to him. Yep.
Okay, I can do that. And then also, now that I'm thinking about it, I requested for Trevor to be part of the Slack channel also.
Oh, okay.
Yeah, so I think you have to allow that.
Do I? All right.
I think so. So yeah.
I'll check it out.
Cool. Okay, I think that's everything. Thank you.
All right, no problem. See you Monday.
Alrighty. Okay, thanks. Bye.